What if the loneliest sound in the universe wasn't silence, but a single unanswered cry? For nearly half a century, a 72-second whisper from the stars, captured in 1977 and named the WOW signal, has been humanity's most tantalizing and frustrating mystery. It was a powerful, anomalous radio blast from the constellation Sagittarius, a cosmic shout that never repeated and never explained itself. It was the ultimate ghost in the machine of the cosmos, a fleeting moment that promised we were not alone, only to be followed by 48 years of deafening silence. We told ourselves it was a fluke, a natural phenomenon we just didn't understand. We had to. But what if the silence wasn't an ending? What if it was just a pause? And what if the second act of this cosmic drama isn't a sound, but a sight, an impossible object hurtling through our solar system right now, following a path that seems to be retracing the steps of that long-lost echo? An object that is breaking all the rules of physics and chemistry. An object that might be about to fly right past our front door. August 15, 1977. At the Big Ear Radio Telescope of Ohio State University, a machine dutifully listened to the cosmos, translating the silent symphony of space onto reams of computer printout. On that summer night, amidst the gentle hum of cosmic background radiation, the telescope caught something extraordinary. For 72 seconds, it recorded a powerful, narrow-band radio signal, an unwavering beacon of such intensity that it dwarfed everything else in the sky. Astronomer Jerry Amon, reviewing the data days later, was so stunned by the perfect clarity and strength of the transmission that he circled the corresponding alphanumeric code, 6EQUJ5, and scribbled a single, now legendary word in the margin. Wow! The signal was a perfect enigma. It bore all the hallmarks of a deliberate artificial transmission. Its frequency, 1420 MHz, is the frequency of neutral hydrogen, a universal constant that any intelligent civilization would likely recognize as a cosmic hailing channel. Its strength was staggering, many times more powerful than any transmitter on Earth. Yet, despite frantic efforts to rescan that same patch of sky in the days, months, and years that followed, it was never heard again. The WOW signal became a ghost story for astronomers, a singular event that hinted at something profound but offered no proof. It was a cosmic knock on the door from a visitor who immediately vanished, leaving humanity to wonder for a lifetime if we had imagined the whole thing. For 48 years, the mystery held. The consensus settled on it being a 1 in a billion natural event, perhaps the light from a distant star being gravitationally lensed, or some other as yet unknown astrophysical phenomenon. The idea of it being a genuine alien transmission was relegated to the fringes, a romantic but ultimately unprovable notion. The universe, it seemed, had returned to its silent, indifferent state. Then came 3 Atlas. Discovered by the ATLAS, Asteroid Terrestrial Impact Last Alert System in Hawaii, it was initially catalogued as just the third known interstellar object to visit our solar system, a traveler from another star. The first, Oumuamua, had been a bizarre cigar-shaped anomaly that tumbled end over end. The second, Borisov, had been a more conventional, albeit still extraordinary, interstellar comet. 3I Atlas, however, was different. From the moment astronomers began to plot its trajectory and analyze its behavior, it began to present a series of puzzles that grew more and more unsettling. The bombshell, however, came from a place few expected. The hallowed halls of Harvard University. Professor Avi Loeb, the controversial and unflinching head of the Galileo Project and a vocal proponent of searching for extraterrestrial technology, decided to ask a simple, yet audacious question. Where was this new visitor, 3I Atlas, on August 15, 1977? The task required a colossal feat of celestial mechanics, winding back the clock on the solar system by nearly 5 decades. His team fed the object's current, precisely measured trajectory into supercomputers, accounting for the gravitational pull of the Sun, Jupiter, and every other major body in our solar system. They painstakingly traced its path backward in time, watching as it recrossed the vast empty gulf between the stars. The goal was to see if its path intersected with anything of interest. The result was more shocking than anyone could have imagined. On the exact day the "wow" signal was recorded, 3I Atlas was located in the precise, infinitesimally small sliver of the sky from which the signal had originated. The alignment was perfect. Of course, correlation does not equal causation. The object was still a vast distance away at the time, approximately 600 astronomical units from the source region, 600 times the distance from the Earth to the Sun. But in the silent, three-dimensional emptiness of space, such an alignment is no small thing. Loeb and his team then went a step further, calculating the statistical probability of this alignment being a random coincidence. They ran the numbers for every known comet and asteroid, for every conceivable random trajectory. The answer the computers spat out was staggering. The statistical probability of a random interstellar object being in that exact location, on that exact day, was incredibly, vanishingly low. So low, in fact, that it suggested a 99.4% chance that the object and the signal were somehow linked. The implications were seismic, sending a shockwave through the astronomical community. A 48-year-old cold case had just been blown wide open by a suspect that hadn't even been in the same room. The link, however tenuous, resurrected the most profound question of all. If 3I Atlas was the source of the "wow" signal, what was it? And why had it sent that message? The sheer power required for such a transmission from 600 AU away was mind-boggling, far beyond what any natural known phenomenon could generate. It would require an energy source and a focusing mechanism that screamed technology. It would be like seeing a single bonfire burning brighter than a star. Natural sources, like pulsars or emissors, emit energy in broad, sweeping waves. The "wow" signal was a laser-focused beam. The mystery of its purpose deepened. Was it a greeting? A simple "hello" broadcast across the interstellar void? That seemed unlikely, given that it was a one-time-only event. A message sent across light years would surely be repeated to increase the chances of it being heard. Was it a warning? A cosmic flare fired to ward off travelers from a dangerous system, or perhaps to signal a threat lurking within our own? Or was it something else entirely, something we couldn't yet comprehend? Perhaps the signal wasn't meant for us at all. Perhaps it was a communication with something else, something that was already here, waiting. The 48-year journey of 3I Atlas into our solar system suddenly looked less like a random passage and more like a long-planned arrival. The ghost from 1977 had returned, and this time it had a physical form. The silence had been broken, and the questions that followed were more terrifying and exhilarating than the silence had ever been. The connection to the "wow" signal was the fuse, but the powder keg was the object itself. As astronomers around the world trained their most powerful telescopes on 3I Atlas, the data that poured in painted a picture not of a simple rock or a dirty snowball, but of an object that seemed to willfully defy the laws of celestial mechanics. It wasn't just one anomaly. It was a cascade of impossibilities, a stack of statistical miracles that, taken together, began to strain the limits of coincidence and point toward a far more deliberate and disturbing conclusion. Each anomaly, on its own, could perhaps be dismissed as a fluke. But 5 of them, all in one object? That wasn't a fluke. That was a statement. Our solar system is a relatively orderly place. It formed from a spinning disk of gas and dust, and as a result, almost everything moves in the same direction and on the same flat plane, known as the ecliptic. The planets, the asteroids, the comets from our own Oort cloud, they all circle the sun in a vast, counterclockwise cosmic ballet. To move against this flow is to be a celestial salmon swimming against a cosmic river. This is known as a retrograde orbit, and while not unheard of, It is exceedingly rare for objects originating within our system. 3I Atlas, however, wasn't just retrograde. It was moving against the grain of the entire solar system. But the true statistical shock came from its inclination. Not only was it moving backward, but its path was perfectly aligned with the flat plane of the solar system. Imagine firing a bullet from a distant star, billions of miles away, and having it not only travel through the solar system, but do so perfectly parallel to the thin, invisible disk upon which all the planets orbit. The chances of this happening by accident are astronomical. It is like throwing a frisbee from a mile away and having it slide perfectly flat under a closed door. Avi Loeb's team calculated the odds of a random interstellar visitor possessing both a retrograde orbit and a near-zero inclination relative to the ecliptic. The answer was 1 in 500. It was the first sign that this was no ordinary traveler. Its path seemed less like a random wander and more like a carefully chosen route. If the trajectory was improbable, the timing of its arrival was so fortuitous as to be almost unbelievable. Plotting its path forward revealed a series of planetary encounters that looked less like a coincidence and more like a meticulously planned itinerary for a grand tour of our inner solar system. The object's path was set to bring it for close, observable passes of not one, not two, but 3 key planets: Mars, Venus, and even the colossal king of the solar system, Jupiter. To understand the improbability of this, one must grasp the scale of our solar system. It is, for all intents and purposes, empty space. The planets are microscopic specks in a vast, dark ocean. For an object arriving from another star to happen to come close enough to even one planet for detailed observation is lucky. For it to line up flybys of 3 is statistically staggering. It is the equivalent of a tourist arriving in a country for the first time without a map and randomly stumbling upon the 3 most important historical landmarks in the correct sequential order. Perhaps the most theatrical and suspicious of its behaviors was its impending disappearing act. Every comet and asteroid that passes through our system has a perihelion, a point of closest approach to the Sun. This is typically when the object is at its brightest, its most active, and its most observable from Earth, as the intense solar radiation causes it to vent gas and dust. It's the main event for astronomers. 3I Atlas, however, had arranged its schedule with uncanny precision. Its perihelion, the moment of its peak activity when it would reveal the most about its nature, was set to occur while it was in a perfect solar conjunction. In other words, it would reach its most interesting point while conveniently hidden from Earth's view, directly behind the Sun. This wasn't just bad luck for astronomers. It was strategically perfect if the object had something to hide, to perform any kind of maneuver, to fire an engine, to release a probe, to change its course. The most efficient time to do so would be at perihelion, using the Sun's immense gravity to amplify the burn in what is known as an Oberth maneuver. And 3I Atlas had arranged to perform this crucial part of its journey in complete privacy, shielded from our prying eyes by the billion-ton fusion reactor at the center of our solar system. The timing was too perfect, suggesting a level of forethought that was deeply unsettling. It was going to perform its most critical action while the curtains were drawn. As 3I Atlas drew closer to the Sun, it began to brighten, as expected. But what it produced was not a typical cometary tail. A comet's tail is formed by solar wind and radiation pressure pushing dust and gas away from the Sun. Regardless of the comet's direction of travel, its tail always points directly away from the Sun. It is a fundamental law of cometary physics. 3I's Atlas broke that law. Observations revealed that the object exhibited a strange, ethereal glow, a coma of ejected material. But this coma was not being pushed back into a tail. Instead, the glow was concentrated in front of the object, facing its direction of travel. It was as if the object was generating a forward-facing shield, or a kind of exhaust. No known natural phenomenon could explain this. A comet does not push its own tail. It has it blown off. This bizarre, forward-facing glow was another piece of the puzzle that simply didn't fit, hinting at an internal process, a release of energy that was not a passive reaction to the sun, but an active, controlled mechanism. The final and perhaps most scientifically damning anomaly was its unwavering trajectory. As 3I Atlas neared the sun, spectroscopic analysis showed it was venting enormous amounts of material, far more than a typical comet. This process, known as outgassing, should act like a series of small, random rocket thrusters on the surface of a comet, causing it to deviate slightly from its purely gravitational path. This non-gravitational acceleration is a well-understood phenomenon and is observed in almost all active comets. Yet, 3I Atlas remained perfectly on course. Despite ejecting a colossal mass of gas and dust, its path did not change by a single meter from what gravity alone dictated. It was as if a cannonball was firing off firecrackers in all directions, but refusing to budge. There is only one physical explanation for this. The object had to be far, far more massive and dense than any comet of its size had any right to be. For the outgassing to have no effect, the object's own mass and inertia had to be so immense that the force of the venting gas was like a fly pushing against a freight train. Statistical models based on our understanding of interstellar objects predicted a certain mass for an object of its brightness. 3I Atlas was orders of magnitude denser. It was built of sturdier stuff. It was not a loose, fluffy snowball of ice and rock. It was something solid, something cohesive, something that possessed a physical integrity that no natural comet could explain. Taken together, these 5 anomalies painted a portrait of an object that was not just unusual, but seemingly artificial. It moved with purpose, on a path of impossible precision, conducting a tour of our system while preparing to perform a key maneuver in secret. It glowed in a way it shouldn't, and was constructed of a material far denser than nature would suggest. The universe is full of strange things, but 3I Atlas was pushing the boundary between strange and engineered. If the 5 physical anomalies of 3I Atlas were a cryptic message, its chemical composition was a confession written in a language every scientist could understand: the language of elements. The study of an object's chemical makeup, known as spectroscopy, is one of astronomy's most powerful tools. By capturing the light from a distant object and splitting it into its constituent colors, like a prism, scientists can see the dark lines where specific elements have absorbed light. This creates a unique chemical fingerprint, revealing what the object is made of. When the James Webb Space Telescope and other powerful observatories turned their spectroscopic gaze upon the faint coma of gas surrounding 3I Atlas, the fingerprint they found was not just alien. It was utterly bizarre and pointed directly to an industrial, not a natural origin. The first major shock was the complete inversion of what we expect from a comet. Comets born in our own solar system are, for the most part, dirty snowballs. Their primary component is water ice, H2O. When they approach the sun, this water ice sublimates into gas, making up the vast majority of their coma and tail. Spectroscopic analysis of 3I Atlas revealed the exact opposite. Its ejected gas was composed of a staggering 95% carbon dioxide, CO2. Water was a mere trace element. This alone was a significant anomaly. While not impossible, it suggested that 3I Atlas formed in a star system profoundly different from our own, perhaps around a carbon-rich star where CO2 ice was more plentiful than water ice. It could be a natural, albeit exotic, object from a corner of the galaxy with a completely different chemistry set. This explanation, while stretching our understanding of planetary formation, was still within the realm of possibility. It was the next discovery that shattered this fragile natural explanation and sent a wave of alarm through the scientific community. As the spectrographs collected more data, they detected the clear signature of a heavy metal being shed by the object: nickel. Nickel is a common element in the universe, often found in asteroids and the cores of planets. But its presence here was accompanied by a glaring, impossible absence. In nature, nickel and iron are cosmic twins. They are forged together in the hearts of dying stars and are almost always found together in meteorites and asteroids, typically in a predictable ratio. Geologically and cosmically, where you find one, you are virtually guaranteed to find the other. Their chemical properties are so similar that natural processes do not easily separate them. The gas cloud around 3I Atlas was shedding pure nickel. There was no corresponding trace of iron. None. This discovery cannot be overstated. The separation of nickel from iron is not something that happens in nature. It is, however, a hallmark of advanced industrial manufacturing. On Earth, we use complex chemical and electrolytic processes to separate nickel from iron ore to produce stainless steel, batteries, and other advanced alloys. To find pure nickel being vented into space, without its iron companion, was like finding a stainless steel spoon in a pristine, untouched fossil bed. It was the chemical signature of technology. The alarm bells rang even louder when astronomers began to track the rate at which this nickel was being produced. As the object crept closer to the sun, the amount of nickel being detected in its coma was not just increasing, it was increasing at an unusually steep, exponential rate. This was not the gentle, steady sublimation one would expect from a warming rock. This was a reaction that was accelerating rapidly, suggesting a process that was being driven by the increasing solar heat in a way that was far more efficient and volatile than simple geology. What could possibly explain this? One terrifying hypothesis began to form. What if the nickel wasn't part of the object's structure, but a byproduct of its function? What if, as it absorbed more and more solar energy, an internal engine or power source was beginning to spin up, and the pure nickel was its exhaust? Or perhaps the outer hull was a sophisticated alloy designed to ablate, to burn off in a controlled manner, as a form of thermal protection, and this process was shedding pure nickel. The chemical evidence was now in direct conflict with a natural origin. The object's composition was wrong, its geology was wrong. It was actively shedding a material that, in its pure form, is a fingerprint of industrial processing. The case for 3I Atlas being a weird comet was crumbling under the weight of hard, chemical data. The object wasn't just behaving like a piece of technology. It was now actively leaking the chemical proof of its artificial nature into the vacuum of space, leaving a trail of evidence that was becoming harder and harder to ignore. The question was no longer just, what is it made of, but who made it, and what is its purpose? With evidence mounting that 3I Atlas was not a natural object, the conversation in hushed corners of government agencies and astronomical observatories shifted from one of discovery to one of risk assessment. The question was no longer just academic. If a technological object of unknown origin and intent was cruising through our solar system, humanity needed a way to classify the potential threat it posed. Into this vacuum of protocol stepped Loeb and his team, who proposed a new system for this unprecedented situation, the Loeb scale. Modeled loosely on the Richter scale for earthquakes or the Torino scale for asteroid impacts, the Loeb scale was a 0 to 10 system designed to classify the potential threat level of anomalous interstellar objects. It was a tool to move the conversation from a binary, is it or isn't it alien, to a more nuanced, what is the probability that it's technological, and what are the potential consequences? A level 0 on the scale would be an object confirmed to be natural, like the interstellar comet Borisov. A level 10 would represent a confirmed extraterrestrial craft on a direct collision course with Earth, an undeniable existential threat. Lower levels, 1 to 3, would indicate objects with some anomalies, but for which natural explanations were still highly plausible. The middle levels, 4 to 6, would represent a state of high ambiguity, where the evidence for an artificial origin was compelling but not yet definitive. The upper levels, 7 to 9, would signify an object that was almost certainly technological and displaying potentially hostile intent. After weeks of rigorous analysis of its trajectory, its bizarre physical behaviors, and its impossible chemical signature, the Galileo project team assigned 3I Atlas its initial rating, a level 4. A level 4 signified a 40% probability that the object was technological in origin. This was a watershed moment. It was the first time a respected scientific body had formally assigned a numerical probability to the idea that an object in our solar system was an alien artifact. It was a chillingly high number, far past the threshold of casual curiosity. A 40% chance of being artificial meant that the possibility could no longer be dismissed. It had to be taken seriously. While the object was not on a direct collision course with Earth, the Level 4 classification forced a darker question to the forefront. Could it become a threat? This is where the trajectory's most suspicious feature, the disappearing act behind the Sun, became the focal point of concern. As the chapter explained, an engine burn performed at perihelion, amplified by the Sun's gravity, could dramatically alter its course. While hidden from our view, 3I Atlas could execute a maneuver that would place it, or smaller probes it might deploy, on a direct intercept trajectory with Earth. We would be completely blind to this action until it re-emerged from behind the Sun in December, potentially with only a few months to react. This possibility brought a grim and controversial theory from the fringes of astrobiology into the mainstream discussion: the dark forest hypothesis. Popularized by author Cixin Liu in his science fiction trilogy, the theory offers a terrifying solution to the Fermi paradox. The question of, if the universe is full of life, where is everybody? The dark forest hypothesis posits that the universe is like a dark forest at night, filled with hidden hunters. Every civilization is a potential threat, and the safest course of action for any intelligent species is to remain silent and hidden. If you detect another civilization, you cannot know its intentions. Is it peaceful? Is it hostile? Given the existential stakes, the only logical self-preserving action is to eliminate the other life form before it can eliminate you. In this terrifying scenario, first contact is not a moment of hopeful communication, but a prelude to annihilation. Viewed through the lens of the dark forest, the actions of 3I Atlas looked far more sinister. The "wow" signal sent 48 years ago could have been a passive scan, a ping to see if any fledgling technological species, like humanity, which had just begun broadcasting powerful radio signals, would respond. Our own radio leakage could have been the rustle in the leaves that gave away our position. The 48-year journey to our system would then be the slow, deliberate approach of the hunter. The grand tour of the planets would be reconnaissance, and the maneuver behind the Sun would be the moment the hunter raises its weapon. The Loeb scale rating of 4 was not just an academic classification. It was a formal acknowledgement of this chilling possibility. It meant that there was a non-trivial chance that the object in our backyard was not just an artifact, but a weapon. The debate shifted from one of pure science to one of planetary defense. The potential for a propulsion burn while hidden from view transformed 3I Atlas from a fascinating scientific anomaly into a potential ticking time bomb. The wow signal may not have been a greeting or a random noise after all. It might have been the sound of a tripwire being triggered. As September gave way to October, a palpable sense of anticipation settled over the global astronomical community. The endless debates, the statistical modeling, and the spectroscopic analyses had taken them as far as they could go. The abstract nature of the threat was about to become terrifyingly concrete. October 3, 2025, was marked on every calendar at NASA, the ESA, and every other major space agency. This was the day 3I Atlas was scheduled for its close flyby of Mars. This encounter represented humanity's single greatest opportunity to get a real, hard look at the mysterious visitor. For the first time, we would get a resolved image of an object from another star system. Orbiting the red planet was a fleet of humanity's most advanced robotic explorers. Satellites like Europe's Mars Express and Trace Gas Orbiter, and NASA's MAVEN and Mars Reconnaissance Orbiter, MRO, had been studying the Martian atmosphere and surface for years. Now their missions were being temporarily rewritten. Their sensitive instruments would be turned away from Mars and pointed toward the incoming interstellar guest. The undisputed crown jewel of this ad hoc observation campaign was the High-Resolution Imaging Science Experiment, or HiRISE camera, aboard the MRO. HiRISE is the most powerful camera ever sent to another planet, a telescopic marvel capable of seeing features on the Martian surface as small as a dinner table from its 200-mile-high orbit. Now this incredibly sharp eye would be turned on 3-eye Atlas. The concept of a resolved image was the key. Until this point, every image of 3-eye Atlas, even from the mighty James Webb Space Telescope, showed it as a mere point of light, a single unresolved pixel surrounded by a faint, fuzzy coma. We could analyze its light, but we couldn't see its shape. The Mars flyby would change that. At its closest approach, 3-eye Atlas would pass close enough to the MRO for HiRISE to capture an image where the object itself would cover multiple pixels. It would no longer be a dot, it would be a shape. The tension in the days leading up to the flyby was immense. At NASA's Jet Propulsion Laboratory, engineers and scientists worked around the clock, uploading new command sequences to the MRO, calculating the precise pointing angles, and running simulations to ensure the best possible chance of a clear image. The maneuver was not without risk. Pointing the aging satellite in a new direction and holding it steady was a complex operation. But the potential reward was immeasurable. The entire debate about 3-eye Atlas could be settled by a handful of pixels. If the resolved image came back showing an irregular, lumpy, potato-like shape, it would be a huge point in favor of the weird comet theory. Nature rarely produces straight lines or perfect geometric forms, but if the image revealed a regular geometric shape, a cone, a cylinder, a disk, or something with sharp angles and smooth surfaces, it would be the smoking gun. Such a discovery would instantly elevate the object from a level 4 on the Loeb scale to a 7 or an 8. It would be undeniable proof of its artificial origin. The fate of another, more ambitious mission also hung in the balance: the potential redirection of NASA's Juno spacecraft. Juno was currently in orbit around Jupiter, its primary mission to study the gas giant nearing its end. A daring, high-risk proposal was on the table to use the last of Juno's fuel for a radical course change after it finished its work. It would be a long, looping trajectory to put Juno on a course for a close-up intercept of 3-eye Atlas in March of 2026. This would give us not just a blurry picture, but high-resolution photographs and direct measurements of the object itself. It would be one of the most audacious feats of celestial mechanics ever attempted, and it was fraught with danger. But the decision of whether to greenlight this Juno intercept mission hinged entirely on what the HiRISE camera would see on October 3rd. A blurry rock would not be worth risking a billion-dollar spacecraft for. A clear image of a manufactured object, however, would make the mission not just worthwhile, but an absolute planetary imperative. On October 3rd, a silence fell over the mission control rooms as they waited for the signal from the Mars Reconnaissance Orbiter, which had to travel for several minutes across millions of miles of space to reach Earth. The data packets began to arrive, pixel by pixel, slowly building the most anticipated photograph in human history. The world held its breath. Was it a rock, or was it a ship? The answer was about to appear on their screens. The images from the Mars flyby, whatever they revealed, were only a prelude to the main event. The entire saga of 3-eye Atlas was building toward a single critical moment of ultimate suspense. October 29th. On this day, the object would reach its perihelion, its closest and most active point in its journey past our Sun. And, with the theatrical timing that had become its hallmark, it would do so while completely obscured from our view, hidden behind the blinding glare of the Sun itself. This was its disappearing act, and it was the perfect opportunity to execute the most strategically significant maneuver in celestial mechanics, the solar Oberth maneuver. The Oberth effect is a principle in orbital mechanics that is both simple and profound. In essence, a rocket engine is most efficient at changing a craft's energy when the craft is moving at its fastest, and an object in orbit around the Sun moves fastest at its closest point, the perihelion. Firing an engine at this moment of peak velocity, even for a short duration, results in a massive, disproportionate change in the object's trajectory and final speed. It's the ultimate gravity assist, using the Sun's own immense gravitational well as a slingshot to amplify the power of an engine burn. To put it in terrestrial terms, imagine a child on a swing. If you give them a small push when they are at the very top of their arc, where they are moving slowest, you barely affect their swing. But if you apply that same push at the very bottom of the arc, where they are moving fastest, you can send them soaring to a much greater height. The solar Oberth maneuver is the cosmic equivalent of that perfectly timed push. For an interstellar craft looking to make a significant course correction within a solar system, there is no better time or place to do it. It allows for a dramatic alteration of its path with the absolute minimum expenditure of fuel. It is the move a smart, efficient, and technologically advanced traveler would make. And 3I Atlas was scheduled to arrive at this perfect maneuvering point, while it was completely hidden from our sight. The period of solar conjunction would last for several weeks. From late October through November and into early December, the object would be lost to us. Our most powerful telescopes, including the James Webb, would be unable to observe it. The Earth, the Sun, and 3I Atlas would be in a straight line, and looking for the faint object would be like trying to spot a firefly sitting on the filament of a searchlight. This period of blindness was the source of immense anxiety for planetary defense experts. While hidden behind the Sun, 3I Atlas could do anything. It could perform a burn to alter its trajectory, perhaps setting a new course for a flyby of Earth. It could deploy smaller probes, sending them on divergent paths throughout the solar system. It could even position itself to enter a stable orbit around our Sun, becoming a permanent and unwelcome new neighbor. We would have no way of knowing any of this had happened until it was too late. Our first indication of a change would come in December, when the object was scheduled to re-emerge from behind the Sun's glare. Astronomers would frantically try to reacquire it, to plot its new position, and compare it to the old, purely gravitational predictions. If the object was not where it was supposed to be, it would be a definitive confirmation that it had used propulsion. It would be undeniable proof of its technological nature. But this confirmation would come at a price. By the time we discovered its new path, it would already be well on its way. Our reaction time would be drastically reduced. If its new course was indeed a threat to Earth, the weeks we spent in blissful ignorance while it was hidden would be the most critical weeks we had lost. The disappearing act was the perfect crime, committed in plain sight yet completely unobservable. As October 29th approached, the world could only wait, staring at the Sun, wondering what was happening on the other side. The fate of our solar system, and perhaps our species, was being decided in secret, and we would be the last to know. As the official scientific narrative struggled to keep pace with the sheer strangeness of 3I Atlas, a parallel narrative was exploding in the digital wilderness of the Internet. While NASA and the ESA released carefully worded statements and preprint academic papers, the court of public opinion was holding a chaotic and far more sensational trial. The information vacuum created by the object's profound mysteries was being filled by a whirlwind of speculation, fear, and conspiracy theories, reflecting a deep-seated public distrust of authority and the frantic human need for answers in the face of an incomprehensible unknown. Social media platforms, online forums, and video streaming sites became the epicenters of this speculative frenzy. On Twitter, the hashtag #JohnAtlasGate trended for weeks, a repository for every unverified claim and wild theory. One of the most persistent rumors, fueled by anonymous accounts claiming to have inside access to radio telescope data, was that the object had already begun to decelerate. Blurry, unofficial graphs showing a slight but steady decrease in its velocity would go viral, presented as leaked proof that the object was preparing to enter orbit and that governments were hiding this fact to prevent global panic. Another popular theory centered on the idea that 3I Atlas was already emitting signals, but that this information was being suppressed. Self-proclaimed audio engineers would post highly processed recordings of cosmic background noise, claiming to have isolated repeating, intelligent pulses hidden deep within the static. These Atlas pulses would be analyzed by online communities, who would find patterns in the noise that resembled binary code or mathematical constants. Despite being easily debunked by professional radio astronomers as pareidolia, the human tendency to find patterns in random data, the belief that we were receiving a message and that they were hiding it from us, became an article of faith for many. The conspiracy theories were not just limited to the object's behavior. Many turned inward, questioning the very reality of the event itself. One prominent theory, popular in anti-government circles, was that 3I Atlas was a grand government hoax, a Project Blue Beam-style psychological operation. The goal, they argued, was to create a fake alien threat to unite humanity under a single world government, distract from domestic political problems, or justify a massive increase in military spending. Every new piece of strange evidence released by scientists was seen not as a clue, but as another scripted element in a global deception. Conversely, a darker theory suggested that the information being released was a heavily sanitized version of a much more terrifying truth. This theory posited that governments knew with 100% certainty that the object was an alien craft and that its intentions were hostile, but were deliberately withholding this information to prevent the complete collapse of society. Proponents of this view would meticulously dissect the language of official press releases, looking for coded words and hidden meanings. A scientist's admission of a statistical anomaly was twisted into proof of a confirmed threat. Every moment a telescope was not pointed at the object was cited as evidence that the powers that be were trying to prevent the public from seeing something they weren't supposed to see. This narrative of a cover-up resonated deeply in an age of rampant misinformation and declining trust in institutions. The scientific process, which is by its nature slow, methodical, and filled with uncertainty, was ill-equipped to compete with the instant, confident, and often more exciting narratives being woven online. While scientists spoke in probabilities and error bars, anonymous YouTubers spoke in absolutes, offering a seductive sense of certainty in an uncertain time. The narrative acknowledged the human element behind this explosion of speculation. These theories, while largely unsubstantiated and often contradictory, were not just a product of malice or ignorance. They were a reflection of a profound collective anxiety. The arrival of 3I Atlas was a direct confrontation with one of humanity's deepest fears and most fervent hopes. The sheer magnitude of the event was difficult for the human mind to process. For many, it was easier to believe in a familiar human conspiracy, a lying government, a secret cabal, than to confront the truly alien and incomprehensible reality that an object of unknown power and intent was silently gliding through our cosmic neighborhood. The conspiracy theories were a psychological defense mechanism, a way to shrink an existential cosmic threat down to a more manageable, human-sized problem. While the public internet was a wild west of speculation, the hallowed halls of academia were descending into their own form of civilized yet brutal warfare. The debate over 3I Atlas was no longer a polite exchange of ideas. It had become what one inside source called an academic bloodbath. The controversy pitted a small group of audacious, forward-thinking scientists, led by the unapologetic Avi Loeb, against the powerful and deeply entrenched mainstream scientific establishment. It was a conflict fought not with weapons, but with preprint servers, peer reviews, and public denunciations, and it exposed the raw human underbelly of the scientific enterprise, where ego, reputation, and a fierce resistance to paradigm-shifting ideas can create a battlefield as vicious as any other. At the heart of the conflict was Avi Loeb himself. A brilliant but famously abrasive theoretical physicist, Loeb had long been a thorn in the side of the astronomical community, with his vocal insistence that the cigar-shaped interstellar object, Oumuamua, was an alien probe. With 3I Atlas, he had doubled down, presenting his chain of evidence: the WOW, signal connection, the statistical anomalies, the chemical signatures, as a compelling, coherent case for a technological origin. He published his findings rapidly on open-access servers like arXiv, bypassing the slow, traditional peer review process to get his ideas into the public sphere immediately. The reaction from the mainstream was swift and ferocious. Many of Loeb's colleagues, who had spent their careers studying comets and asteroids, saw his work not as bold, but as sloppy, sensationalist, and a betrayal of the scientific method. They accused him of leaping to the most extreme conclusion possible, based on ambiguous data. In public statements and on academic social media, prominent astronomers dismissed his papers as unprofessional and pure speculation. They argued that he was engaging in science by press conference and was damaging the credibility of their field in the public eye. The battle became intensely personal. Critics pointed to Loeb's connections with wealthy donors interested in UFOs as evidence that his research was biased. They argued that his Galileo project, founded to search for extraterrestrial artifacts, was an answer in search of a question. The established gatekeepers of academic publishing seemed to close ranks. Loeb's papers on 3I Atlas faced unusual resistance and delays in the peer review process. Reviewers, often anonymous competitors in his field, would return with pages of critiques, demanding impossible levels of proof for his extraordinary claims, and suggesting that the anomalies could be explained by instrumental error or as yet unknown natural phenomena. This resistance was portrayed by Loeb and his supporters as a coordinated effort by academic gatekeepers to control the narrative and suppress a revolutionary idea. They argued that mainstream science had become too conservative, too focused on incremental advances, and too hostile to truly paradigm-shifting discoveries. They saw the scientific establishment as a kind of secular priesthood, protecting its dogma from heresy. The resistance to the 3I Atlas hypothesis, they claimed, had little to do with the evidence, and everything to do with a deep-seated, almost allergic aversion to the idea of extraterrestrial intelligence. To even consider the possibility was seen as a career risk, a slide into the disreputable realm of ufology. This academic civil war highlighted a fundamental tension in science. On one side was the vital principle of skepticism, the demand for rigorous proof, and the maxim that extraordinary claims require extraordinary evidence. On the other was the need for open-mindedness, the courage to challenge established consensus, and the understanding that every great leap in scientific understanding was once considered a radical heresy. The conflict over 3I Atlas was about more than just a strange object in the sky. It was about the very nature of scientific progress. It was a clash of personalities and philosophies, a struggle between caution and courage, between protecting the foundations of existing knowledge and daring to build a new one. The academic bloodbath was a stark reminder that science is not a cold, dispassionate search for truth conducted by robots. It is a messy, passionate, and deeply human endeavor, full of pride, prejudice, and an intense, often brutal, fight for the future of our understanding of the universe. In the midst of the academic war and the public frenzy, a quieter, more methodical group of scientists took a step back. Their goal was not to champion or debunk the technological hypothesis, but to engage in an act of rigorous scientific fairness, to build the strongest possible case for 3I Atlas being a natural, albeit highly unusual, object. They sought to apply the principle of Occam's razor, the idea that the simplest explanation is usually the correct one. And for all its strangeness, the weird comet theory was, in the grand scheme of things, a far simpler explanation than invoking an alien civilization. This chapter methodically deconstructed each anomaly, offering potential, non-technological explanations that, while exotic, remained within the known laws of physics and chemistry. The first and most striking anomaly, its bizarre chemistry, was addressed with a hypothesis rooted in its unknown origins. The object's 95% carbon dioxide composition could, they argued, be explained if it formed in a protoplanetary disk around a carbon star. Unlike our Sun, these stars have more carbon than oxygen in their atmospheres, leading to a chemistry where carbon compounds, including CO2, would be far more common than water. If 3I Atlas was a planetesimal ejected from such a system, its composition would be perfectly natural for its birthplace. The strangeness was not inherent to the object, but to our limited sun-centric perspective. The most challenging piece of evidence to explain naturally was the shedding of pure nickel without any corresponding iron. This was the supposed smoking gun for technology. However, a team of astrochemists proposed a creative, if speculative, solution. They hypothesized the existence of a rare, highly volatile molecule called nickel carbonyl, NiCO4. This compound is known to exist in industrial settings on Earth, and allows nickel to turn into a gas at very low temperatures. They theorized that if 3I Atlas had formed in a uniquely cold and carbon monoxide-rich nebula, this strange molecule could have formed and become trapped within the object's ice. As it approached our Sun, the gentle heat would be enough to sublimate the nickel carbonyl, releasing pure nickel gas into the coma, while the heavier, less volatile iron remained locked within the object's rocky core. It was a long shot, a molecule never before detected in space, but it was not physically impossible. Next, they tackled the impossible trajectory. The retrograde orbit perfectly aligned with the ecliptic plane, with its 1 in 500 probability, was framed as a statistical fluke. In a galaxy with hundreds of billions of stars, constantly ejecting objects into interstellar space, even 1 in 500 events are bound to happen eventually. We just happen to be the ones to witness it. It's a form of the anthropic principle. We see it because it's here, and if it had been on a different path, we wouldn't have seen it. The convenient grand tour of the planets was similarly dismissed as observation bias. We see it as a grand tour because those are the planets we have observers near. The immense mass and density, inferred from its refusal to budge despite massive outgassing, was perhaps the easiest to explain away. Our sample size of interstellar objects was, at this point, a grand total of 3. To declare that 3I Atlas was too dense was to assume that the first two, Oumuamua and Borisov, were representative of the entire galactic population. What if they were the outliers? What if 3I Atlas, dense and robust, was actually the norm for interstellar travelers, and our own solar system's fluffy comets were the fragile exception? We simply didn't have enough data to say what a normal interstellar object should look like. Finally, the connection to the wow signal was addressed as the most tenuous link of all. The natural explanation was that it was simply a monumental coincidence. The universe is vast and old, and improbable alignments happen. They argued that linking a 48-year-old unrepeated radio signal to a completely different physical object based on a single positional alignment was a classic case of confirmation bias, of wanting to see a pattern so badly that you ignore the overwhelming probability that there is none. This chapter served as a crucial scientific reality check. It methodically offered a chain of plausible, naturalistic explanations for every single anomaly. Each explanation was, on its own, a bit of a stretch. It required a rare type of star system, a never-before-seen molecule, a statistical fluke in trajectory, and a dismissal of what seemed to be a perfect alignment. However, as this segment argued, was that entire chain of unlikely natural events truly less probable than the single monumental explanation of an alien spacecraft? For many scientists, the answer was yes. Occam's razor still favored the weird comet theory, however dull it might be. At least it would remain the favored explanation until a piece of definitive, irrefutable proof, like a clear geometric image from the Mars flyby, emerged to tip the scales for good. As 3I Atlas prepared for its disappearing act behind the sun, humanity found itself at a profound and unsettling crossroads. The furious debates, the cascade of anomalies, and the impending moment of truth had forced a confrontation with our own place in the cosmos on a scale never before imagined. Regardless of whether the object was a comet or a craft, its passage through our solar system had already changed us forever. It had exposed our scientific squabbles, our societal anxieties, and our complete and utter unpreparedness for one of the most significant events in human history: confirmed contact. The immediate future was a flurry of planned observations. Beyond the critical Mars flyby, the European Space Agency's JUICE, Jupiter Icy Moons Explorer, spacecraft, on its long journey to Jupiter, was being repositioned for a long-range look at the object from a different angle in the solar system. The data from JUICE would provide a crucial second perspective, helping to nail down the object's trajectory and perhaps analyze its coma from a different vantage point. But all these observations were a prelude to the single overwhelming question that loomed over humanity. What happens next? If 3I Atlas re-emerged from behind the sun on a new, non-threatening trajectory, the debate would continue, but the urgency would fade. It would remain a profound mystery, a cosmic ghost that graced us with its presence and left us with more questions than answers. But if it re-emerged on a trajectory headed toward Earth, or if it was confirmed to be artificial, humanity would face a dilemma of existential proportions. The debate over METI, messaging extraterrestrial intelligence, versus SETI, search for extraterrestrial intelligence, would erupt from a theoretical academic argument into an urgent global crisis. Should we attempt to send a message? Proponents would argue that this was a once-in-a-civilization opportunity for unprecedented knowledge, a chance to learn the answers to our oldest questions. Are we alone? What else is out there? To remain silent would be an act of cosmic cowardice. But the chilling logic of the dark forest hypothesis would cast a long, dark shadow over this optimistic view. If contact invites predation, then sending a message would be like a lost child shouting in a forest full of wolves. It would be a potentially suicidal act, gambling the entire future of our species on the hope that the visitor was friendly. The risk, critics would argue, was infinite, while the potential reward, however great, was not. This dilemma highlighted humanity's shocking lack of preparedness. There are no established international protocols for first contact. Who would speak for Earth? The United Nations? A coalition of spacefaring nations? Would a single nation take it upon itself to act, potentially endangering the entire planet? The political and social chaos that would ensue from a confirmed discovery would be immense. Religions would be thrown into crisis. Economies could collapse in panic. The event would be a mirror reflecting both the best and worst of our species. The story of 3I Atlas thus concludes not with an answer, but with a question mark of cosmic proportions. It has forced humanity to look up from its terrestrial squabbles and confront the vast, silent, and potentially crowded universe we inhabit. It has served as a fire drill for a fire that may or may not be coming. The object, whatever its true nature, has become a catalyst, a focal point for our hopes, our fears, and our profound ignorance. We are left waiting. waiting for the images from Mars, waiting for the object to complete its secret maneuver behind the Sun, waiting to see what emerges from the glare in December. Humanity stands at a crossroads, one path leading back to a familiar, lonely universe, the other leading to a future that is completely, terrifyingly, and wonderfully unknown. The silence from the stars has been broken, and we are about to find out if what follows is a conversation or a conflict. The journey of Three-Eye Atlas, whether it ends as a footnote in astronomy textbooks or as the preface to human history's final chapter, leaves us with a profound and deeply personal lesson. The universe, in its infinite strangeness, has held up a mirror to us. In our reaction to this object, we see our own reflection, our capacity for brilliant deduction, and our tendency toward baseless fear, our hunger for knowledge and our addiction to certainty, our ability to collaborate on a global scale, and our instinct to retreat into tribal squabbles. The story teaches us that the greatest unknowns are not always in the cold vacuum of space, but in the complex, uncharted territory of the human heart and mind. How do we face something that defies our understanding? Do we react with open-minded curiosity or with fearful, dogmatic rejection? The academic bloodbath shows us that even the most brilliant minds can be blinded by their own paradigms, while the explosion of conspiracy theories shows how easily fear can sever our connection to reality. The advice from this cosmic tale, the wisdom we can apply to our own lives, is threefold. First, embrace the uncertainty. Life, like the universe, will always present us with anomalies, with events and people that don't fit our neat little boxes. The healthiest response is not to force an immediate answer, but to learn to live with the question, to gather more evidence, and to be willing to change your mind. Second, listen before you transmit. In a world where everyone is shouting their own opinions, the story of the wow signal and the dark forest hypothesis is a powerful metaphor. Sometimes the wisest course of action is to listen, to observe, to understand the landscape before you announce your presence. This applies to a new job, a new relationship, or a difficult conversation. And finally, remember our shared vulnerability. Faced with a potential cosmic threat, our national borders, our political affiliations, and our cultural differences become profoundly meaningless. We are all passengers on the same tiny, fragile vessel. The challenges of our time, be they celestial or terrestrial, demand that we act not as warring tribes, but as a unified crew. So I leave you with these questions to ponder. If you learned, with 100% certainty, that an alien probe was on its way, what would be the very first thing you would do? What single message would you want to send on behalf of humanity, knowing it might be our only statement to the cosmos? Thank you for joining me on this incredible journey to the edge of our understanding. I wish you and yours the very best of health and clarity of mind in these fascinating times. If this story has sparked your curiosity and made you think, please consider subscribing to the channel for more explorations into the greatest mysteries of our world and beyond. Stay curious. Stay safe.